This is Algebra 2, Chapter 13.1 through 13.4 review. This first part we're looking to solve triangle ABC. To solve means to figure out all of its sides and angles. We have a right angle. The hypotenuse is 11. This might be hard for you to notice, but 46 degrees is the angle. So 90 minus 46, because the acute angles of a right triangle are complementary, I know that we're going to have also, that should be 46. So this would be 44. So if this is triangle ABC, let's say ABC, the measurement of angle A would be 44. Now to figure out the adjacent side of the 46, we could use cosine of 46 degrees equals the adjacent side, which is CB, over 11. Put it over 1 and cross multiply. So 11 times the cosine of 46 equals CB. So with our calculator, you need to be sure that you're in degree mode. So 11 times the cosine of 46 gives you 7.64. 7.64. That was for my CB length. To find the opposite, we're going to say sine of 46 equals AC over 11. Across from the 46 would be our opposite side. So again, we would cross multiply to get 11 times the sine of 46. $7.91. Let theta be an acute angle of a right triangle. Find the values of the other 5 trigonometric functions. So what we should do here draw a right triangle. You know that sine means opposite over hypotenuse. So there would be our theta. The hypotenuse is 6. The opposite side is 5. So to calculate what your missing side is, you could use Pythagorean Theorem. So 6 squared equals 5 squared plus our unknown, so we get the square root of 11 to be x. So to figure out sine of our theta, we already know that that's 5/6. Cosine of theta is adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. Now notice that the square root of 11 is in the denominator, so we should rationalize the denominator to get 5 root 11 over 11. So cosecant, which is a reciprocal of sine, would be 6 over 5. Secant, the reciprocal of cosine, would be 6 over the square root of 11. Rationalize the denominator. And then tangent. Let's do the reciprocal of 5 over the square root of 11, so we don't have to re-rationalize it again and then reduce. Number 3, draw an angle with a given measure in standard position. Find one positive and negative coterminal. So 250 degrees. I know that that's more than 180. That's less than 270. That's more than 125. So if we take, to figure out a negative, we're going to take 255 and subtract 360 from it. And that should give us negative 105. That would be the distance around here. And another positive get my other I in there. The other positive is going to be the 255 plus 360. And that will come out to 615. So you have a negative that would point in the same direction. You have a positive that would loop all the way around again. 1,000. Well, it's 360 degrees to go around once. 720 to go around twice. 720, 810, 900 degrees, 990, and 100 more degrees. Not 100 more degrees. 990 is 10 more degrees. Anyway, you got 10 extra degrees. So that's 1,000. Now, what's another positive angle that would land in the same spot? There's several of them. Every time we loop around, we'd be able to hit another. So you can take your, for a positive, you can take 1,000 and subtract 360 from it. So that should be 640. You could subtract 360 from that again. And that would be 280. For the negative coterminal, we'd take the 280 and we would subtract 360 again. We'd get negative 80. Here we have 20 pi over 3. Well, that's not a normal size of an angle that you would think of for the unit circle, but you know where pi over 3 is. That's pi over 3, that's 2, that's 3, that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 pi over 3. So a positive is going to be 2 pi over 3. And negative is going to be 1, 2, 3, 4. Negative 4 pi over 3. Notice I did not convert over to degrees and then calculate it. I worked right with the radians. That's one way you could do it. Another way to show your math would be to say 20 pi over 3 minus 2 pi. Well, when you subtract 2 pi, that would be minusing 6 pi over 3. So you now have common denominators. So that would be 14 pi over 3. Minus 6 more pi would be 8 pi over 3. 6 more pi would give you the 2 pi over 3. So those are different ways that you could show how you came up with 2 pi. We're going to convert these degrees into radian. So take your negative 135. If we want radian, then we need the pi to be on top and the degrees to be on bottom. So when we reduce this, we see that 45 goes into this guy 3 times. 45 goes into 184 times pi. $11 pi over 6. To convert that to degrees, we're going to put the degrees on top and the radian on bottom. Cross that out. 6 goes into 6 once. 6 goes into 180 30 times. And when we multiply, we get 330 degrees. Negative 5 pi over 4. You should have an idea where this is on the unit circle, just like you could have with 11 pi over 6. If you want the pi to cross out, the pi has to be on bottom. We get 225 degrees. Use the given point on the terminal side of the angle and standard position of the 6 trig functions. So negative 9 over and 12 up. So we're negative 9 for the adjacent side. We're 12 for the vertical side, or the opposite. So now we have to find the hypotenuse. Negative 9 squared plus 12 squared equals our radius squared. So the radius is 15. So now, from our angle that we'll be working with, that helps us identify that this would be your opposite, adjacent, and hypotenuse. Find the 6 trig functions. Sine of our theta is going to be 12 over 15, which reduces to 4/5. 3 goes into 12 4 times, 3 goes into 15 5 times. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Notice we're in the second quadrant, so of course tangent should be negative. So would cosine, and sine would be positive as you go up. Cosecant is going to be the reciprocal. Secant and cotangent. I was just thinking of this cotangent, and I didn't remember saying that word already. We already did the 6 trig functions. Up here, we did secant and cosecant, cosine and secant, tangent. This guy should have been cotangent. Okay, number 10. -6, -9. Make your right triangle with the x-axis. Looking for the radius. So 36 and 81 comes out to be 117. So we're going to get the square root of 117. So the sine, the angle we're working with is here at the central angle. So the opposite over hypotenuse. You have to rationalize the denominator. You notice that 3 goes into 9 3 times. 3 goes into 117 39 times, and that also can be reduced. So just a way to check, to be sure that your work is accurate, you could take the square root of 117 divided by 13, and you get this decimal of 0.8320. And if we take the original answer, it would actually be a negative, by the way. Take our 9 divided by the square root of 117, and we got the same exact decimal. So this is always a good way for you to check to be sure your simplifying is accurate. Cosine is going to be adjacent over hypotenuse. Rationalize the denominator. Three goes into 6, and 3 goes into 117. Tangent is going to be opposite over adjacent. So a negative and negative make a positive. Divide both by 3. Cosecant is the reciprocal, so you get negative square root of 117 over 9. Secant is the reciprocal, so we get negative 117 over 6. And cotangent would be 2/3. Make a sketch, find the reference angle. So at negative 260, that would be almost all the way to negative 270. So when we talk about a reference angle, we're actually talking about the angle that it takes to come back down to the x-axis. So if this is 260, that is 80 degrees short. Let's see. Take your 260 and this is 180. We're going to take that 180 away from it. So let's actually make that a positive just to let our calculations come out clean. Take away the 180 and we get 80 degrees. That would be a reference angle. Five pi over 3. It's 1 over 3, 2 over 3, 3 over 3, 4 over 3, 5 over 3. So if that's 5 over 3, that makes this a pi over 3. So one way to say it is the whole circle all the way around, which is 2 pi, not counting that 5 pi over 3. On the back side, we're looking for the sine of theta. Typically, when we talk about sine, we're talking about values in the first or fourth quadrant. Sine of 0.3 would be something like that. So we're going to say sine inverse of 0.3. We'll use our calculator. Comes up with 1746. Now that's our reference angle. So now this is telling us to go to the second quadrant with that same reference angle. That's the full 180 minus that amount. So when we subtract 117, well, not 117, but when we subtract 17.46, we get 162.54. Tangent. Tangent, we typically look at the first and the fourth quadrant also. 0.6, I suspect would be something like that. we're supposed to look for an angle in the other quadrant that is positive, which would be between 180 and 270. So we're going to say tangent inverse of 6 so we're looking for what angle makes a tangent of 6, and that's 80.54. So if we're going to go 80.54 into the third quadrant, we're going to say 180 plus 80.54. So take your value, add 180 to it, and we get 260.54.